All right, today's about trapezoids and kites, but before we do that, as always, I'm going to review a couple things first, actually just one thing. And that one thing is an isosceles triangle. And so we talked about this in the fall when we talked about other types of triangles, but isosceles triangles are those ones that have two congruent sides and then this third side that's not necessarily congruent to the other two is called the base. Okay, so this bottom side on this triangle here is called the base. And so the two angles that touch the base, also called the base angles, are going to be congruent. In other words, angle C is going to be congruent with angle B. Okay, that's an isosceles triangle. And you'll see in a minute why I wanted to review that really quick with you. Okay, the first new thing we're going to talk about is a trapezoid. And so a trapezoid is a polygon with one pair of parallel sides. So if I look at this trapezoid I have here, I can tell obviously that this side right here and this side right here are not parallel, because if I kept extending those lines out, they'd run into each other. And we know parallel lines don't touch. And so on this trapezoid that I've drawn here, that's my one pair of parallel sides. Those are going to be called the bases. So in an isosceles triangle, there's only one base, right? In that isosceles triangle we had up here, there was only one base, but in a trapezoid, there are two bases, right? Both of the sides that are parallel to each other are called the bases. Okay, that's a trapezoid, a four-sided polygon with one pair of parallel sides. And then there's a special type of trapezoid called an isosceles trapezoid. Okay, so same thing. We have one pair of parallel sides because it's a trapezoid, but now what we have are both pairs of base angles being congruent. Right, so we have two bases. In both bases, their base angles are going to be congruent. In other words, angle A is going to be congruent with angle B, and angle D is congruent with angle C. The legs, right? So if I go back up to the isosceles triangle, I forgot to mention this, but these two sides that are congruent to each other are called the legs. So the sides that are congruent to each other that are not the base in an isosceles trapezoid are also going to be congruent, right? So the bases are not congruent, and you can see that by looking, but the two legs are going to be congruent. And then you'll notice on number 4, I kind of scratched something out. I had it wrong. Consecutive interior angles are supplementary only if we have a pair like these two or these two, okay? So for example, in this isosceles trapezoid, angle A plus angle D equals 180, and then angle B plus angle C is going to be 180. Okay, so only non-congruent consecutive angles are supplementary. Next thing is a trapezoid mid-segment, and this will work for regular trapezoids or isosceles trapezoids, it doesn't matter. So again, in a trapezoid we have one pair of parallel sides these are called the base, and the other two sides are called legs. Not legs, just legs. All right, a trapezoid mid-segment is if I find the midpoint of both legs and then I draw a line that connects them, that line is called a trapezoid mid-segment. And a couple things about the trapezoid mid-segment. One, it's parallel to the bases. So this line that goes from E to F, so EF is parallel. So EF is parallel to AB and parallel to DC. All right, the other thing is that if I want to know how long EF is, if I want to know the length of segment EF, I can use this formula. EF is going to be half as long as the two bases added together. So my two bases are AB and DC. All right, so let's say I knew that AB was 10 units long and I knew that DC was 20 units long. And I want to know how long EF is. Here's how I'd figure that out. EF is half as long as AB, which is 10, plus DC, which is 20. So 10 plus 20 is 30, and half of 30, or 0.5 times 30, is going to be 15. So EF, that the trapezoid midsegment here, this line is going to be 15. And so there's the formula, but another way to think about it is that a trapezoid midsegment is basically halfway between the sizes of the two bases, right? 15 is halfway between 10 and 20. So if that's easier for you to think about it that way, do that. If you like using the formula, use the formula. All right, a kite. The last type of quadrilateral we're going to talk about is a polygon with two pairs of consecutive congruent sides. And all that means is that these two sides are congruent and these two sides are congruent. So all four sides, you can tell this by looking, aren't congruent with each other, but AB is congruent with AD and BC is congruent with DC. The diagonals, so if I draw diagonals in here from A to C and then from B to D, those two diagonals are going to be perpendicular. And remember, perpendicular means two lines that cross or intersect at a right angle. And so that means that line segment AC is perpendicular to line segment BD. Last thing, one pair of opposite angles that are congruent, right? In this kite, that's going to be angle B and angle D. So angle B congruent to angle D, or if I want to be more precise, I would say that angle ABC is congruent with angle ADC. All right, in this problem, I'm going to try and figure out whether these points, QRST, I'm asked to find whether they make a trapezoid, and if it's a trapezoid, whether it's an isosceles trapezoid or not. And so this is kind of a long, drawn-out problem, and it's really two separate questions, but I'm going to take my time on this, so please pay attention while I do it. Okay, first thing we have to do is plot the points. So I'm told Q is at 2, 5, so that's Q. R is at -2, 1. S is at -1, -6. And T is at 9, 4. So I'm going to go off of my grid a little bit. Here's 7, 8, 9, and then up to 4. So there's T. And then I'm going to connect them with lines. I don't necessarily have to here, but it'll just kind of help me see what I'm working with. All right, so there's a trapezoid, it looks like. If I want to figure out whether it's a trapezoid at all or not, I know that at a bare minimum it has to have one pair of parallel sides. And so I can tell right away that if I were to extend this line out and this line out, they're not going to be parallel. They're going to cross each other at some point. And so the only possibility for parallel sides would be this and this right here. So what I want to know is RQ parallel to ST? That's the first problem I need to figure out. To figure out whether they're parallel or not, I need to look at their slopes, right? If I want to know if two lines are parallel, I need to look and see if they have the same slope. And so once again, the formula for slope is m equals y2 minus y1 over x2 minus x1. And so I'm going to do that for both RQ and for ST. And if what I get matches up, then I'll know I at least have a trapezoid. All right, so RQ, here's x1, y1, x2, y2. So I'm going to have 5 minus 1 over 2 minus -2. 5 minus 1 is 4. 2 minus negative 2 becomes 2 plus 2, which is 4. So the slope of RQ is just 1. So I'm going to do the same thing for ST. X1, Y1, X2, Y2. So I'm going to have 4 minus negative 6 and 9 minus negative 1. 4 minus negative 6 becomes 4 plus 6, which is 10. 9 minus negative 1 becomes 9 plus 1, which is 10. 10 divided by 10 is 1. And so since the slopes of those two lines match up, they are indeed parallel, so I know I at least have a trapezoid. Now I want to figure out whether it's an isosceles trapezoid or not. So I can't really measure angles to tell if my base angles are congruent or not. But what I can do is look and see if the diagonals are congruent. Right? So if you go back when I first introduced an isosceles trapezoid, one thing I know is that the diagonals in an isosceles trapezoid, so in this case that would be SQ and RT, those two would have to be the same length. The way I'm going to figure that out is with the distance formula, or another way, the way that I've been referring to it in class is the Pythagorean theorem, and that's where we make the triangles. We make a right triangle, and in this case SQ is going to be my C for this triangle that I've drawn in so far. So C squared equals A squared plus B squared. I'll call this side A, and how long is this line? Well, it's 1, 2, 3 units long. And B is going to be a lot longer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm going to stop there for now, and I'm going to start working on the length of RT, and you'll see why in a second. So now I'm going to create another right triangle here, and RT is going to be my C on this one. So this time RT is what I'm calling C. And again, C squared equals A squared plus B squared. So for this one, if I'm up here at 4 and I go down to 1, well, that length is going to be 3. So I'm going to have 3 squared. And then how far is it from R out to this angle? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I could keep going with the math, but I already know that 3 squared plus 11 squared is going to be equal to 3 squared plus 11 squared. And so I could figure out what that actually was and then take the square root of it, but I don't need to do that in order to be able to say that the two diagonals in that trapezoid are congruent. In other words, QS, that diagonal from Q to S, is congruent to RT, the other diagonal. And so the answer to the second question, is this an isosceles trapezoid, is also yes. Okay, this one wants me to find a missing angle measure within an isosceles trapezoid. So if I have an isosceles trapezoid, I know a couple of things. The important one here is I know that the two pairs of base angles are going to be congruent with each other, right? And I know this one is a base because it's one of the sides that's parallel with the other side, which is then my other base. And so the two pairs of base angles are going to be congruent to each other. Another thing I know is that consecutive but non-congruent angles are going to be supplementary. So in other words, in this case, angle Q plus angle R is going to add up to 180 degrees. Okay, that's only if we have an isosceles trapezoid. Okay, those two angles are going to add up to 180. And so if I'm looking for angle Q, which is what the problem is saying here, I'm just going to have to solve this equation after substituting in 110 for angle R. So angle Q is going to come out to be 70 degrees. Next one, another isosceles trapezoid. And so the important thing to do, I think, right away when you get information like that is go ahead and mark in what you can. And so it's already got markers telling me that side WZ is parallel to side XY. It's already telling me that my two legs, YZ and XW, are congruent. The thing that it doesn't have marked yet is that the two diagonals are congruent. In other words, side XZ, or I should just say line segment XZ, is congruent to line segment YW. That's going to be important here. Okay, it wants us to find PW. Find PW. So I'm going to highlight the thing that it wants to know. It wants to know just this part. How long is that part? If XZ, so from right here all the way to right there, is 18, and PY, this part right here, is 3. All right. What I know is all the way from X to Z is 18. So if XZ is 18, then YW has to also be 18. Right? And this XZ is broken up into two parts. There's kind of the long part and the short part, right? Well, if YP or PY is 3, then XP is also going to be 3. Right? These two shorter parts are going to be congruent to each other. Well, if I have 3 up here, how many more are left over to get from P to Z? In other words, if XP plus PZ adds up to 18, right? Let me draw what I'm talking about. If X to P is 3, and then I have to get from P to Z, and I don't know that part, but I know that 3 plus X equals 18. What is that bottom part equal to? Well, I'll just subtract 3 from both sides. X is equal to 18 minus 3, which is 15. In other words, I know that from P to Z, this part right here is 15. Well, if this segment here from X to Z is 18, and it's broken up into a 3 and a 15, then this one over here is going to be the same thing, right? And the part that we're actually looking for down here is PW, and so my answer to this question would be PW is 15. Now we're going to find some trapezoid midsegments. I have a trapezoid here, QRTU, and I know, or I'm told, that QR is 4, UT is 16, and I want to know what VS is. Well, the formula to find a trapezoid midsegment is going to be VS, which is the midsegment, is equal to 1/2 of the two bases added together. So 1/2 of 4 plus 16. 4 plus 16 is 20. Half of 20 is 10. And so my answer here is that VS would be 10 units long. That's for number 17. Number 18 gives us different information. So I'm going to clear that out. It says VS is 9 now, and UT is 12, and it wants us to find QR. All right, well, in this case, since I know the midsegment, since I know the length of the midsegment already, I'm going to put that here. That's going to be equal to 1/2 times this base, which I'm just calling X right now because I don't know what it is, plus this one right here, which is my other base. So I have 9 equals 1/2 times X plus 12. What I'm going to have to do now is distribute this 1/2 by X and 12. So now my equation is going to be 9 equals 1/2 times X. We'll just call that 1/2 X. And 1/2 times 12 is 6. Okay, so I want to get X by itself, so I'm going to subtract 6 from both sides. So I'm going to have 9 minus 6, which is 3, equals 1/2 of X. All right, if I have half of X and I want to get to a full X, a full 1X, I have to multiply that side by 2. Anything I do on one side, I have to do on the other. So 2 times 3 is 6. 1/2 x times 2 is just x. So x, in other words, QR, is going to be 6 units long. All right, last two problems about trapezoids and kites. Okay, so we did some problems with trapezoids. Now we're going to do a couple with kites. Kites are those ones where we have two pairs of consecutive congruent sides, one pair of opposite congruent angles, and then the diagonals are perpendicular to each other. So what it wants to know on number 25 is WP. It wants to know the length of WP, and if I just kind of take out this piece of the kite, it looks something like this. There's X, here's P, here's my right angle, and here's W. And then I know, or the picture says that WX, this part is 6, and it says that XP is 4. So I'm going to use the Pythagorean theorem. That's the a squared plus b squared equals c squared. And the thing I've told you guys you have to be careful about is making sure you get the right C. C is always the side that's across from or opposite of the right angle in your right triangle. So I know C is 6, and I know one of my legs is 4, and what I'm actually looking for here is the other leg, right? WP I'm just going to call B for now, right? So 4 squared is 16 plus b squared equals 6 squared, which is 36. Subtract 16 from both sides. B squared is going to be 20, and I don't want to know b squared, I want to know b. So the last step here is going to be to take the square root of both sides. So my answer, b is going to be the square root of 20, or I could say 2 times the square root of 5, or I could plug that into a calculator and get a decimal. Either way is fine, but there's my answer. Last one, angles now, rather than line segments or sides. Says the measure of WXY. So I like to identify my angles as soon as I see them. WXY. So what angle is it talking about? It's talking about the angle made by these 3 points. So it's talking about this right here. This angle is 13x plus 24. Then I have, I'll do it in a different color. I have WZY. WZY. Talking about this angle right here. That one it just says is 35. Third angle it gives me is ZWX. So ZWX. So this angle right here says that angle is 13x plus 14. All right, so I know 3 of the 4 angles inside of the kite, but what I know about kites is that they have one pair of opposite congruent angles. So whatever this angle is up here that I've drawn in gray is going to be congruent to this one down here. So this one is also going to be 13x plus 14. All right, the next thing I have to remember is how many degrees there are inside of a 4-sided shape. Right? And so you know that a triangle has 180 degrees, and if you think back a few days ago, hopefully you remember that 4-sided shapes, doesn't have to be a square, but any 4-sided shape is going to have 360 degrees inside of it. So 360 degrees is going to be all 4 of these angles put together. So 35 plus 13x plus 14 plus another 13x plus 14 plus 13x plus 24. Okay, so I have a big mess there. I'm going to try to clean it up by combining like terms. My numbers are 35, 14, 14, and 24. Because I'm feeling lazy, I'm going to use a calculator. $35, 14, 14, 24 is 87. And I'm going to add up my x terms. 13 plus 13 is 26, plus another 13 is 39. So I have 39x. That's all equal to 360. I'm going to subtract 87 from both sides. And if I'm doing my math right here, it'd be 273 equals 39x. I'm going to divide both sides by 39. X is going to be 7. Okay, but it doesn't want to know x. It wants me to find zyx. Okay, zyx is this angle right here, which I know is 13x plus 14. So the last step here is just to use substitution. So angle zyx is equal to 13x plus 14, which is the same thing in this problem as 13 times 7 plus 14. 13 times 7 is going to be 91. And then 91 plus 14 is going to be 105 degrees. So angle zyx, 105 degrees. Remember to smash that subscribe button.